problem of problem by we in this video we are going to evaluate the integral of a function by using the inverse of a Laplace transform. So the topic will be concerned about this. So in whole video I'll do the example of integrals so that we can understand how to use the inverse of a Laplace transform to find the integral of a function that we cannot determine. So I have a book, so I am taking a question from the book so that we can easily write down it. So one question 0 to infinity cos tx square. The first question is proof that L by 2 pi by 2p L by 2. So the question is given by tx square dx equal to L by 2 pi by 2t L by 2. So this is the question, we have to prove it. So how do we prove this question? So let's look at the procedure what I follow so that you have to follow. So basically let f of t is equal to what? 0 to infinity cos tx square dx. We assume that this is our function, okay? So if this is a function, so Laplace transform of f of t is, we know what is nothing but 0 to infinity est f of t dt, okay? F of t dt, obviously. So that give us 0 to infinity est 0 to infinity cos tx square dx dt, obviously, okay? So now what can I do? Now we can change the order of an integration. Now we can change the order of integration. So changing the order of integration, we can write down it est cos tx square dt is and dx 0 to infinity, okay? So what is this? What is this? What is this? Look at this. This is nothing but Laplace transform of cos tx square, okay, dx. So we know what is the Laplace transform of this. This cos tx, okay, remember cos tx square, okay. So Laplace transform of this is nothing but s square plus here the t will be act as a coefficient of x square. X, here I am taking x square, so that gives us x to the power 4 ts 0 to infinity dx. So we have to integrate in with respect to dx. So let's suppose x square equal to what? Tan theta, okay. So 2x dx will give us 2 sec square theta d theta. So dx will give us sec square theta d theta upon 2 tan theta, okay, obviously. So 1 minute, let's suppose as s tan theta, okay. So when we put the value in equation 1, so that gives us s square plus s square tan square theta, and obviously that is sec square theta d theta. When we change the limit of an integration, that gives us root pi by 2, obviously, okay. So now taking as s square is common, so 1 plus tan square theta and sec square theta 0 to pi by 2, and here will be root tan theta. So this will be cancelled. Here s1s will be cancelled. So since s will act as a constant, s here act as a constant, so s will be also 0 to pi. Under root tan theta we can write is sin theta by minus 2, okay. So I am erasing it, okay. Cos theta 1 by 2 d theta. So recall the formula of a gamma function that we can use that as okay. So root 2s will be outside, okay? Root 2s I am taking as root 2s here, root 2s will be outside. After that, we know that what? So we know 0 to in pi by 2, okay? Sin p, sin theta p, cos theta q d theta is equal to gamma p plus 1 by 2 gamma q plus 1 by 2 upon gamma p plus q minus 1 by 2 into 2. That is the rule. So use this rule of when a gamma function. I am using it, okay? If I write it, so please rewind the video, you can write it. So that gives us root s by 2. Here gamma will be 1 by 2 plus 1 upon 2 and gamma 1 by 2 plus 1 upon 2. Similarly 2 into 1 by 2 plus 1 by 2 minus 1 upon 2. So minus 1 by 2 cancel. So what we get? Will be 2 gamma. Okay, sorry, yes, papa, no, papa. So that will be plus 1, so 2 upon root s, okay? So gamma half and gamma 3 by 2 upon 2 gamma. So evaluate this. So that will give us 2 into root s upon 2. Gamma will be give us 1 by pi by 2, okay? Here that give us 1 by 2 into gamma. So 1 by 2, here root pi will be pi and 2 will be 4. 4 will be come into under denominator will give us what? 16 root s. 16 root s. Here, remember. So pi by 16 will be act as a constant, root s will be outside. Yes. So we have to find the integral of a function. So in case we have assume that f of t is equal to what? Cos px square 0 to infinity dx. So now we have to find a Laplace f of t. So we have to take the, so f of t will be Laplace inverse of Laplace transform. So pi by 16 will be outside. Okay. So inverse of Laplace transform is root s. Remember the, okay. Now what will be the value? Now here that will give us one thing you have to remember. We know if gamma n factorial, okay, gamma n plus 1 upon Sn plus 1 equal to what we get? We get, obviously this is a Laplace transform of Sn. Since here n plus 1, so that obviously give us gamma. So in case Sn plus 1, okay, so that give us Laplace transform of Sn upon gamma n plus 1. So when we find this, that give us pi by 16 and pi by 2 t. Sorry, that is not L, that is should be 1. Okay, so that give us 1 by 2. So if any calculation mistake make it, I am giving your sense, not 2 pi by 2t here L by half. So that is the proof. In this way we can, in this manner we prove it. So I think you have write down it. So I have make it some descriptive. I have written it descriptive so that there is some maybe problem. Obviously you have to be problem. So I will try to clear the right in clear way. So I am erasing it to get it, the concept of inverse of how to use the Laplace transform of a function. That is way. So I have erased it. So next question is so find the Laplace transform. Find cos x square 0 to infinity dx equal to prove that what? half upon pi by 2 under root pi by 2, that is we will get it 1 upon pi by 2. Okay, so that is our concept. So what we do, let's f of t is what, 0 to infinity cos x square dx. So Laplace transform of f of t is will give us Laplace transform of f of t, what will be to 0 to infinity est f of t dt. Okay, so 0 to infinity ex t cos 0 to infinity cos x square dx into dt. So changing the order of integration, so that give us est cos x square dt 0 to infinity dx. So what is this? This is nothing but Laplace transform of cos x square, okay, dx. So when we find a Laplace transform of this give us s square, s upon s square plus 1 into dx. Okay. S square plus upon dx. So there you have not to find it. You can do this part. We have to fit what we have to fit. Okay, I am doing this as well as manner. So why I am doing this? So in case what we get 0 to infinity, we have to fit. So x square dx is nothing but 1 upon pi by 2. Okay, pi by 2 root t. Okay, if t equal to 1, if we suppose to t equal to 1, that give us 0 to infinity cos x square dx is equal to 1 by 2 pi by 2 upon 2. That is nothing I have to prove. I am giving the another example of so I am erasing it. That is the part of you can prove it. I will not cut it. So you can do this. So let's find the integration 0 to infinity et x square dx equal to, that is your part, you have to do it. So you can do it. Can you do it? So 1 2 3, pause the video, solve, find it, proof. What do you do? F of t I am giving it, you can have to prove it. You have to prove dx. Okay, so Laplace transform of f of t is what will be 0 to infinity e s t f of t dt. So 0 to infinity, what s f of t is what, e s t and e t x square dx 0 to infinity dt. So changing the order of integration, we get est, okay, e t x square dt dx. So that is the Laplace transform. You cannot, you have do not add this. So Laplace transform, this is nothing but e t x square into dx. So find a Laplace transform of this. Laplace transform of exponential x will be, what is the Laplace transform? So that will give us s upon 1. So t here will be t x square. So x square dx 0 to infinity. Okay, so when we find it, so that give us integral, when you put the value, tan inverse x by root s upon root s 0 to infinity. Putting the value, we get root s upon pi by 2. Okay, root s upon pi by 2. So Laplace transform of f of t is what, pi by 2 upon 1 by root s. So f of t will be what, inverse of Laplace transform, f of t L inverse. So that give us our result. So pi by 2 upon pi by 2. That is the way you can have to prove it. So I already prove it in front of I think you get it, the concept of behind it. So do like, share, subscribe. Now follow for more video. Thank you.